Hi, good morning, respected lecturers and my supervisor, Dr. Wang. My name is Wang Qinglan. Today, I'm pleased to present my final project titled Sales Forecasting and Customer Preference Analysis for the Food and Beverage Industry. This research focused on applying machine learning and data analysis method to improve restaurant sales prediction and understand customer buying behaviors. In this presentation, I will introduce the research background, objectives, methodology, result, and conclusion. It's the executive summary. This project mainly focuses on two analytical directions. The first part is predictive operations. I developed the gradient regression model used post-stress action data. The model was optimized through time series validation and achieved a low prediction error. The final RMSE value is approximately $485. This forecasting result can help restaurants improving inventory planning and reduce unnecessary food waste. The second part is customer insights. I applied Cummings clustering and I pre-oriented to identify different customer groups and discover menu combination. These findings can support better marketing strategies such as personalized promotions. Problem statement. The food and beverage industry generate large amounts of transaction data every day. However, many small and medium-sized restaurants still depend on experience-based decisions. There are three main challenges. The first challenge is understand data. Although restaurants collect sales records and customer information, they often cannot transform this data into useful business insights. The second problem is kitchen waste. Without a current demand forecasting, restaurants may prepare too many ingredients. This leads to higher cost and food waste. The third challenge is static promotions. Without customer preference analysis, restaurants cannot understand which products are usually bought together. Therefore, this research uses machine learning and data analytics method to solve these problems. Research objectives. Based on these challenges, this research has three main objectives. The first objective is descriptive analysis. This step aims to discover sales patterns, peak hours, seasonal demand, and popular product categories. The second objective is predictive forecasting. Machine learning models are developed to predict future restaurant revenue. The goal is to provide accurate forecast and support inventory management. The third objective is customer preference analysis. By using clustering and association mining, this research can identify customer groups and discover relationships between menu items. Together, these three objectives create a complex analytical framework. Literature review. Previous studies have applied different forecasting models. Traditional methods such as RIMA are useful for simple time series forecasting. However, they have difficulty dealing with complex and non-linear patterns. For example, holiday effects and sudden changes in customer demand. On the other hand, deep learning models such as IOSTI can capture complex relationships. While they require large datasets and high computational resource. This may not be suitable for small and medium-sized business. Another limitation is that previous study many focus on forecasting. They often ignore customer behavior analysis. Therefore, this research develops an integrated framework combining sales forecasting and customer preference analysis. Methodology. For methodology, this research first designed a database architecture. The database used a star schema model. The fact table record individual sales transactions, the dimension table, story order information, and product details. After database preparation, data pre-processing was performed. Therefore, there are several steps. First, data cleaning. I removed the upload record and quantity outliers. Second, data transformation. Revenue data was adjusted to improve statistical stability. Third, future engineering. I created a new feature, including calendar information, ingredients, and averages. Finally, the dataset was divided by time. Data from January to October was used for training. Data from November to December was used for testing. This method prevents data leakage and improves the model evaluation. Temporal demand diagnostic. Before building the model, I analyzed sales model. The analysis discovered three findings. First, lunch and dinner pursuit contributed around 69% of daily sales. This shows the important peak demand percent. Second, weekly sales gradually increased from Monday and reached the highest level on Friday. Third, large-size product generated the highest revenue. This finding can support restaurants to important inventory planning. Several forecasting models were compared. The optimized gradients Bruce regression model achieved the best performance. Compared with traditional model, GBR can capture complex relationships, for example, time pattern, product feature, and customer demand change. The optimized model reduced the test RMSE to approximately $485. The result shows that machine learning can provide useful forecasting support for restaurant optimistic. Customer preference analysis. For customer analysis, I used K-means clustering. The model divided transactions into different customer segments too. For example, segment C0 represent high volume customers. These customers usually purchase larger quantities. Segment 2 represent premium customers. They prefer high value product and contribute more profits. Besides, I priori analysis discovered useful product combinations. Restaurants can use the result to design better menu bundles and promotions. Conclusion. In conclusion, this research developed a complete analytics framework. The forecasting model can help restaurants predict future sales and reduce waste. Customer preference analysis can help business understand customer behaviors and improve marketing strategies. Overall, this study shows how machine learning can transform restaurant data into useful business insight. That's all for my presentation. Thank you for your time and attention. Thank you.